Hello, everyone, and welcome to today's webinar titled Designing and Implementing Microservices. Our speaker today is Michael Forrester. Michael is a 20-year IT industry veteran and an Amazon authorized instructor whose passion is to train, lead, and create technology expertise so that technology teams can deliver software better, faster, smarter, and with visibility and transparency back to the business. Whether it's rolling out a whole new technology for team delivery, training the Uber nerds on cloud, container, and microservices, or coaching others on how to effectively inspire the technical team and engineers in your organization, Michael's focus is to elevate and inform one person at a time. Gotta love that. Now, before we get started with the webinar, I want to talk about the functionalities. During the session, everyone's microphones will be muted. So if you have any questions, please enter them in that Q&A box at the bottom of your screen. We're going to have a dedicated question and answer session at the end of the session, but don't hesitate to post those questions whenever they come up. Today's webinar is being recorded and we'll send a copy to everyone who registered by the end of the week. All right, let's get started. You can take it away, Michael.
Awesome. All right, thank you for that, Michelle. I appreciate that. All right, so introduction has already been given. I'm Michael Forrester. I'll be your primary guide and facilitator today for our exploration of designing and implementing microservices. So what we're going to focus on, we're going to talk about what we're going to talk about, and then I'll kind of rehash it at the end again, is that we're going to talk about how do we get to the design of microservices, some definitions, some principles to consider, and then how do we go from design to implementation, some kind of implementation processes, some evolutions there. And then when we're implementing microservices themselves, what do we want to think about? What are the best practices? What are some things to consider also when we're actually doing our implementation? So what are microservices? What is the official version? Well, most people refer to Eric Evans's books about domain-driven design, but microservices have been around for quite some time, at least the concept, but there's been this driver, especially over the last 6 to 7 years, where microservices have gained momentum for a variety of different reasons. But a good starting place is James Lewis's kind of foundational article on microservices, where he described microservices as an approach to developing a single application, has a suite of services, not just a single process, but a suite of services. And each of these services is running in its own process and communicating with lightweight mechanisms. And nowadays that would be APIs, RESTful services, right? And these individual services that make up this application suite or product, they each are centered around single business capabilities, such as like billing or profiling or presentation layer, and they're independently deployable by fully automated deployment machinery. So the idea here is that that we're taking what was previously all of the business concerns and we are separating it out into single, independently deployable, scalable, and manageable services. And these services, by the way, just as a little preview, are supported and managed by teams who are super focused on that services business domain. That's the official version. So a picture is always worth 1,000 words. So here on the left, we have a monolith. And monolith, by the way, means one stone. So sometimes I refer to them as macro services. And in that context, what we're talking about is we're talking about a single runnable process, usually on a single server, that contains a bunch of business concerns. And on the right, we have a bunch of microservices, and there are a bunch of independent processes. They might also be running co-located on the same server, especially if you're using containers. And each of those governs one subsection of the business concerns. So talking about the left for just a second first, the monolithic application is going to take like profiling and billing and presentation and a bunch of the business concerns. Let's say inventory is in there as well. And those are represented by all of the odd colored shapes that are inside on the left on those little white boxes. And as you can see, the orange, the red, the burgundy, the blue, the green, those are all business concerns, and they're all talking to each other through basically inter-process, inter-memory, right? It's all just contained right in one memory space. And when you need to deploy more orange, because let's say all of a sudden your billing is getting really heavily hit or heavily consumed, you actually have to scale the whole thing because they're all tightly coupled. There's no independence around scalability, deployability, and therefore performance. On the right-hand side, we have microservices, and what you've done is you've taken each of these, what were previously kind of just contexts in memory in a single application, or even libraries or frameworks, and you've made them independent. And as you can see, for example, the orange shapes, there's 5 of those, and there's only 3 of the green shapes, because in this particular drawing, you didn't need as many of that particular business concern. Let's say it was billing versus profile versus inventory versus like streaming, if we were doing, like, for example, Netflix. And so what happens is, if you need more green, for example, let's say that was streaming, you would just independently add more of the green processes and or containers or whatever unit of deployment you were using. You would just add more of those, and there would be one team and one data store that team would manage that would serve those green processes. And so it isolates kind of the evolution, because what happens is that previously we're developing one process that would handle all of our business concerns, and over on the right, we've fractionated that single application into several smaller services, each of which focuses on one and only one business concern. So what is the more complex answer? Because Michael, we've talked about a lot of stuff here, right? So the first is just really the componentization, or creating division of services. How do we separate things into individual business concerns, and at what level of granularity do we do that? If we do billing, for example, let's say billing is one of our first microservices, because we're going to slice pieces off of our monolith and we're going to do a migration. And let's say we're going to tackle billing. Is billing so big that we might need a billing subservice, right, for credit cards versus PayPal or GPay or some other service, or can that all be contained and managed by one team? So the first start when you do microservices is that you are basically taking these business services and you're slicing them up. You're taking these concerns and you're slicing them up. They are organized around business capabilities, meaning, again, what are the business concerns? For example, if you were Netflix, you might have streaming, you might have personalized recommendations, you might have trending items, you might have, what did we just buy? And all of those would be services that would provide information and feedback back to the user. Now, the idea here is that these are products, not projects. And the mindset there is that when you go to a microservices model, you are, in a sense, turning to traditional, hey, I've developed it, and now I'm going to hand it to a maintenance team. You're turning that on its side. You're basically saying, if you build it, you're going to run it, which means that you now own a product from conception all the way to maintenance and delivery, and you're going to own that whole life cycle as it iterates. And so you're not doing a project where you just develop some software and then give it to a maintenance team or an operations team. You are now a product owner, and you're now part of a cross-functional team that will own this microservice for its entire life cycle. Part of this also, when we go to microservices, is that we want the network, we want to assume that the network is simple. Some people call that a dumb pipe, but it's a simple pipe. Meaning we're not passing it to a service bus that's going to do ETL or any kind of data transformation, right? We are taking care of all of that in-house, and we are offering to publish what we can do through these smart endpoints or standard interfaces. Also, we call them now APIs, RESTful APIs. And that could change over time. Maybe there's a new technology in 10 years, but that's what we're doing now and have been doing for quite some time, is that we're publishing RESTful interfaces, these smart endpoints, and they act as an abstraction layer to connect with all the classes and other items on the back end. Part of this also, when you run microservices teams, is that you are moving to a more decentralized kind of governance model, where you're saying these teams can run whatever technology for database, whatever technology frameworks and libraries they need. They can even use whatever deployment model they need, as long as they meet the business concerns. Now, does that mean everything becomes decentralized? No. You might still need single sign-on, and that might be a cross-cutting concern. You might still need centralized logging. So all of these microservices might need to talk to a centralized logging service. All of these microservices might need to talk to a centralized authorization, authentication, and identity service. But for the most part, you are disseminating and delegating power down to these microservices and subsequently to the teams that manage them. So the idea here is to empower these teams, and the cost of that empowerment is they take full responsibility for production running, usage, visibility, telemetry, reliability, everything. As a result of that, there's also decentralized data management because, for example, the profile microservice might need its own profile database that's very different from the billing database. And they're going to be different from a security concern standpoint as well. And if the billing team needs to talk over to the profile team, they're going to do it through RESTful APIs. No other service will have direct access to another service's database, meaning that the billing team is not going to talk directly to the profile database. They have to go through an API because that database is a dependency for that team and no one else gets access except for the service in question. So you're going to take that previous big database that handled all of the monolith concerns and you're going to take data out and fractionate it out for the microservice in question. There are obvious costs in terms of complexity and some replication and caching for that, but for the most part, data goes to where the service lives. The other part of that is that because these are microservices and now you're taking what was previously a monolith that handled a lot of business concerns and you're breaking it out into smaller services, you have to become really good at infrastructure automation. Because you took something that probably has 10, 20, 30 microservices now, and you're now replicating it across a larger infrastructure, and you've got all these tiny little components that are sitting there, and when one of them fails, your service could be down. And so you've got to get really good at deployment, you got to get really good at self-healing and troubleshooting, get really good at automated testing all these pieces for interoperability, not just at a macro level with the product, but also individually with the microservice itself. So you've got to become really strong at infrastructure automation, but that's a key part of like microservices. If you're doing microservices, this is a component of it. Also, when you do microservices, you want to design for failure. Assume that you're not going to have access to your own database or someone else's API or some, like, what do you do? Graceful failover. Here's a good example of that. When you go to Netflix's page and you load up your own personal homepage, there's a series of like, here's what's trending, continue watching this, here's what's recommended for you, here's our top 10 in the United States. And when one of those microservices fails, you don't even know. All of a sudden your personalized recommendations are off the page, but you don't know because instead they just tell you, hey, this is what we've bought lately. Do you want to watch the latest version of The Flash? And you might go, well, that's not a personalized recommendation. I'm not even interested in The Flash. But you didn't even know that that microservice failed. All you saw was a change in your presentation layer because it failed gracefully and just replaced it with something else that might be less relevant, but still shows Netflix content. So you want to design for those kind of failures, anticipate failure and design for it. And then of course, evolutionary design, which is also known as, in a sense, as iterative design. You want to evolve services. So because you are running a product and not a project and you own it as it runs through this life cycle of concept and features to delivery and concepts and features to delivery, you're going to evolve these services because typically you're going to start with a monolith with your startup or business model or even new idea, and you're going to evolve to microservices. So evolution is a huge part of microservice design because that's why we're doing it, is so we can get to smaller batch sizes with one team that does one thing and does it exceptionally well for the business. So that was the more complex answer. So the simple answer, because I like to end with something that's a little more digestible, right, than all that complexity I just kind of threw at you, which is that they are composed of services or many applications that are available on a network through a machine interface. For example, an API. The size of these services is important because it's going to be one or a subset of one business concern. That's what microservices are. And there are system level optimization goals, improving changeability, improving speed to market. There are a bunch of outcomes of this that are all natural byproducts of moving to a smaller, more focused application, right? And that's the simplest answer for what microservices represent. Now, somewhere in there, how small is small for a microservice? Well, as long as you're meeting one business context and it's independently scalable and deployable, you're there, managed by one team. So I will tell you this, is that most of our architecture decisions, just as an additional corollary to why we would do microservices, is that people are hot and excited about microservices now because it reduces coordination costs. I heard, I think it was Ward Cunningham in 2003, he said, Technical debt is that feeling you get when you go to make a change to an application. You know, that sinking feeling where someone comes to you and says, hey, you know, we need to change the billing module. And you're like, oh man, the billing module? God, it's got so many dependencies and it's so brittle and it doesn't have any tests. You know, that feeling you get when you go to make a change to code. That usually means that you have technical debt. And that's the natural evolution of what happens with a monolith, particularly when you don't continually refactor or improve a monolith. Microservices can still suffer from that problem, but when you're using microservices, you're greatly reducing coordination costs because you don't have to coordinate with another team. As long as you publish an API or RESTful interface, that contract, and you don't change that contract, you don't change the interface, you can add to the interface, but you can't change the contract. As long as you're doing that, then you don't necessarily need to coordinate with another team. If you're serving through your interface pizza, hot dogs, and tacos, and you decide that you want to add sushi, you can add sushi. But as long as you don't take away pizza, hot dog, and tacos through your interface, no one's going to complain because the way that they've interfaced with your system is still standardized. And if you want to add sushi into that, no one's going to care, right? Except for the people who want sushi, who have probably asked you for it, hopefully the business. That would be the idea. So it's about minimizing coordination costs so that you can take a team that can go and iterate fast without breaking any contracts with anybody who might be using their services. That, by the way, has to be done in a secure manner. Obviously, safety in terms of reliability and testability is there, and it must be simple. If you're making things super complex, that typically won't work. But it's about keeping that locality and that simplicity in the team that's making the decisions. So the other part of that is that why would we choose microservices? Because it allows for technological heterogeneity. It allows us basically to not have to like coordinate Java calls with Java like in constraints. If everything's an API and it's published and it's well known and it's well formed and it's easily consumable, then the underlying classes, subclasses, frameworks, libraries, or whatever backend technology we're using doesn't matter. I don't need to know that you're using MongoDB on the backend versus Cassandra. That's not important to me. If I try to retrieve data off your API, can I get it? That's what I'm interested in. I'm not tied into what technology you're using. And so technological heterogeneity, where it's basically allows you to mix and match technologies as the team sees fit, that microservices team sees fit. That's another why for microservices, because it allows for evolution. And of course, you don't have to coordinate deployments anymore. You imagine with a monolith, you have to have like 6 or 7 modules all tested and integrated and regression test and working together. With microservices, again, if you're publishing through a consumable standard interface, like a RESTful API, then you can deploy independently as long as you're not doing any breaking changes. You can, by the way, do breaking changes with your contract. Just know that you want to give people lead times to change how they're interacting with your API if you decide to go that route. But that's another why for microservices, is that partition scalability and independence of deployment. Another piece to this is that you might have a bunch of teams working in modules on your monolith, and because they can't deploy independently and they can't go fast independently, you might have one team that has a different level of velocity than another team just because of the complexity of the business concern they're handling. And if you can separate that off and make it independently deployable and scalable, that also means you can take that team and isolate them as well, so that let's say Amazon's 2 pizza team can go as fast as they want as long as they don't make any breaking changes. And so then that allows all these teams to, in a sense, decouple their schedules and allows them to form in a way that allows their mindsets and their local ideologies to take root in their team. And so it reduced the cost of coordination, which is really what we're looking for. We want teams that want to go fast, that can go fast, to go faster, so they can iterate through features and ideas. And teams that need more stability and slowness because of the complexity of what they're dealing with, they can go slower. And both teams can operate in independent schedules without dependencies forcing everybody to the lowest common denominator of speed. That's what we've seen with monoliths, is that you will always deploy at the rate of your slowest team. Microservices breaks that. The other piece, of course, is that because the dependencies are removed, there's no more necessary, you don't have to coordinate life cycles anymore. I need feature A in this module before I can release feature B. that might still be true. There might still be some dependencies, but for the most part, you can just deploy independently and implement features, and then you can toggle them on when team A has theirs on, right? And so dependencies also get less tightly coupled because you can just roll them out when you're ready, and then you can move on to the next feature. Product owners love that. Again, this allows you to go faster, but you still are the cost of you taking that going faster in time to market is smaller batch sizes, smaller concerns, but far more responsibility for security, stability, all of the operational concerns. So yay, all your problems are solved. You've gone to microservices, right? Unfortunately, nothing's a panacea. If that was the case, well, we would have all dropped what we were doing and already moved over, right? So here's some other design considerations to think about now that we've talked a little bit about the what and the why of microservices. First, and this, by the way, is always true in technology, people are the biggest challenge and they are also the solution. So when you design, you want to keep people in mind because they're either going to help you or hinder you depending on what you do. And you want to make sure that your designs, when you go to microservices, that you keep people first. And here's a few questions to think about. One, when you design, let's say you're going from a monolith to microservice and you're designing your first microservice, who is going to be writing, maintaining, testing, and supporting your microservice? Do they have the skills? Are they on board? Are they interested in it? Do they buy into the story, or do they at least disagree and commit? Who is going to be doing the operationalization? Who's going to be doing the testing? Who's going to be doing the patching? Don't worry, it's going to be somebody on your team, but do you know who that is, and do they have the skills to support what you're trying to achieve? Two, how will people outside of the core team access the service? Hopefully, today your answer is an API. If you're offering something that's a little more tightly coupled, I'd recommend that you look at that. But how are you going to publish that API? Are you going to have documentation, endpoints? Is it going to be remarkably independent? Like, what are you going to do to make that work for people? What technologies are you going to use? Are you going to use MongoDB, Cassandra, OrientDB, right? Are you going to use the cloud service? Are you going to use RDS? You're going to use Dynamo. You're going to use DocumentDB, which is really just Mongo, right? Are you using it for a graph database? You're looking for Neo4j. What core technology? What frameworks are you going to use? You're going to write it in Go because you really want, gRPC to give you lightning fast backend services, or maybe you're going to go Node because you've got, React and Angular. You need all kinds of stuff for the front end. Is what we are doing when you're designing a microservice going to meet the goals for the customers of the business? So if you're publishing an API, how is that information going to get to the customers? What if the customer is like Netflix? Oh, you need the presentation microservice to accept and be able to talk to your APIs because you've got the recommender and you're going to publish those recommendations out through the presenter, which Netflix uses to present their webpage. Oh, yeah, you probably want to get comfortable talking to their API and understand how they're going to consume and what data formats they're looking for. I want to make sure that's working as well. And then what are the coordination costs? If, for example, you're the billing team and you're going to retain all of the, for example, the user IDs, which is a unique number that identifies users into your entire organization, what are you going to do when every other service hits your service to get the user ID because they need to know what it is for security or for, credit card or for profile or for recommender? Are you going to offer, maybe there's a separate service for that? Maybe you're going to offer it, you're just going to beef up your services to handle it. So remember, there are coordination and dependency costs. If you're involved in any of those chains, how are you going to handle that, right? And who's going to do it? The other piece is, how do we right-size services? The questions here are you handling one and only one business context, or are you doing a subset of a business context? Is your process independently deployable and scalable? There's a little cutoff there. I'm sure that was me. Is our process independently deployable or scalable? That's what it says, is a service right-sized? And does it handle one business concern? The other is, we want to build services only. We want to build services that do one thing and one thing well. And when we do that, we're shifting complexity. Like you hear this battle cry, for example, for Kubernetes. And I'm a Kubernetes specialist, so I love Kubernetes. I think it's great. But Kubernetes shifts what was previously an application developer's responsibility around, encryption and circuit breaking and all of these other kind of mandates, and it moves it more towards the DevOps/operational side. Remember, these problems still have to be solved. Who's solving them? If you're not solving them, somebody else is. So when you go to design your microservices and you're solving problems, make sure you know that if you, oh, we'll just get rid of that whole piece of complexity. Who's going to solve it? Who's going to do circuit breaking now? Who's going to do end-to-end encryption? Who's going to do backups? Who's going to maintain 5 nines? If you're not handling the presentation layer, is there a team that's now doing the presentation layer? How are they handling that? You want to be prepared, because like, who's going to do that offloading? What's the cost? Typically, the cost of giving responsibility for complexity to somebody else is control. That's fine. For example, developers, if you decide to use, like, for example, service mesh with Kubernetes, circuit breaking is now no longer going to sit. Time to lives are no longer going to sit with the application developer. That pattern is going to actually go with operations. But now that you guys are all on the same team, you guys can control that. But that means that someone or a team of people in your little microservices team is going to handle that. Is that person ready to do that? Do you have the technology? Do you have answers for those questions? And you really want to focus on your core business domain. If you're doing credit card processing, don't get into profile management. That's not what your microservice is about. And if you want to manage multiple microservices with a single team, that actually is totally fine. Just make sure that you don't exceed a certain number of microservices. I would say, in my experience, no more than 3. And the microservices all have to be related to a single business domain. For example, recommenders. Ideally, though, 1 microservice, 1 team. That's it. You do want to, I think, look at cloud native architectures. And by the way, I'm not distinguishing between public and private cloud. I'm not throwing that out there. But do note that there are some references here to necessarily public cloud, because one of the battle cries I hear for large enterprise companies that have 100,000 plus users, whatnot, is, well, we don't want to get vendor lock-in. Well, just be aware that every design decision you make offers some kind of technological lock-in. It's fine if you choose Java or Node or Go or Rust or whatever. Guess what? You are, in a sense, there's going to be a migration cost to get out of that technology, right? So cloud's no different. But there are choices. Some choices that are better. So I'll pick on AWS for a second, because I'm an Amazon authorized instructor, and so I pick on them all the time. Is that okay? So you're like, well, we really want a great data store. But I think we're going to use RDS, which is the relational database service. If you use Amazon's relational database service, by the way, it's offering standard technologies. It's Oracle, MSQL, MariaDB, Postgres, or MySQL. Guess what? If you rip that database out and run MySQL on another system and you move your application over there, it's going to behave exactly the same way it did on RDS, because RDS is just a relational database service offering open source databases. But let's say instead you're like, Amazon told us about Aurora, which is a cloud native database that mimics Postgres and MySQL, and it's like 3 to 5 times the performance depending on which flavor that you're using. We're going to use that. Well, guess what? You can't rip that out of AWS, so that's a different technological decision. Or let's say you use DynamoDB, which is their NoSQL service. That's an invested decision. Is that a problem? As far as I know, AWS is a great partner. But if your business is saying to you, you know what, AWS has started to compete with us from a ad tech perspective, and so we need to make sure that we're more abstract and flexible, then yes, by all means, be flexible. Just know, though, that managed services are out there in a cloud native architecture to offload complexity and responsibility for you, sometimes at the cost of control and cost, like dollars, right? So you need to ask yourself the question is, like, do we go with a single vendor or do we go multi-cloud? Just know that if you go multi-cloud, then you need an abstraction layer. Could that be Kubernetes? Sure. Could it be virtual machines? Sure. That's not a problem. Do we need to stick with generic services like MSSQL and MySQL and whatever? Sure, you can do that. Do we need to do a third party like MongoDB Atlas and just spread MongoDB love all across our cloud providers and we'll just use that? Sure, you can do that. Just know that there's costs for all of that, but be prepared to leverage cloud as much as possible. And if you put private cloud in place, then there's a different conversation. You'll still be using the same open source technologies, but is it API driven? Does it actually support a cloud API driven approach? So the second question is that, assuming that cloud and microservices can go together like peanut butter and chocolate, they can be enablers of each other, how far do we go, right? Do I go ahead and go to DynamoDB, which is a NoSQL data store, and I do auto scaling, and I get into DAX, which is the in-memory data store that can sit on top of DynamoDB? Do I go far down the rabbit hole and get single millisecond performance from my database for my API? Or do I go with an abstraction layer like Kubernetes, which honestly is not going to get you single-digit millisecond response times? And when you run data stores on Kubernetes, there's going to be some complexity because it's got state. Do I do that because I need the control and I want to run multi-cloud? Something to think about. So, and if you do go multi-cloud, how do you minimize dependencies? Well, you got to get as abstract as possible. So something to think about when you're designing your infrastructures is how much is this decision going to lock you in? But you want to go cloud native, even if it's like, for example, VMware or not OpenShift, OpenStack, or any of the other kind of private cloud providers that you can look at. Now, this is going to be a little bit of a mouthful, so I'm going to skim this. Just know that 12-factor apps, 12factor.net, is another aspect that you want to think about when you're looking at microservices, at designing microservices, is that obviously you want to use like revision control, and I hope you all are. Although I still have run into people where it's like, yeah, well, we're using kind of older revision control and it doesn't really allow us to track, and that's fine. Evolve towards revision control. 2, make sure that you're isolating and declaring your dependencies, hence why you want to store your database with your microservice and not let anybody else talk to your database so they can't wreck your database because that's the dependency. You want to make sure that your configuration is stored in the environment, and you want to get to infrastructure as code in that context. So C1 and 3 kind of together, right? Make sure that you can automatically provision, deploy, test, automate, do everything you need to with your microservice. Obviously, databases are a backing service, so you want to treat them as an attached resource. But there could be other resources that are attached. Like let's say you add a search database in addition to an OLTP database. That's a dependency. Bundle those together, right? Make sure that you're using separate build and run stages, right? Make sure you're executing your app as one or more stateless processes. There seems like there's one missing there. You want to make sure that you scale out via the process model. So do multi-threading, do sub processes as needed. And then you want to maximize your startup time with fast startup and graceful shutdown. You want to fail fast, and when you fail, you want to fail gracefully. Reference that Netflix reference I made earlier, where when you go and look at all their recommenders, when one of those recommenders fails, it just disappears off the page. Another thing just moves to the top. You don't actually know the microservice failed, and then you refresh the page, and guess what? Your personalized recommendations are back because that microservice blipped for just a second, but you didn't even know that Netflix had a service outage. You want to keep development, staging, and production as similar as possible. This is one of the great battle cries, by the way, with containers, is because it adds environmental idempotency. Basically allows you to run stuff in your laptop. It's in a container. It's got all the environmental context, and then it stays the same as it moves through, right? We love that. But you can do that with virtual machines as well, and you can do that with other services. So don't let that be the only way that you can solve that problem. It just happens to be a great way to solve it. Treat logs as event streams, so make sure that you're capturing all the data from logs as much as possible, and just treat them as continuous real-time events that are streaming to you that you need to take in, and preferably make searchable, store, centralized, coordinate. The whole UTC time zone thing can really blow people's minds when they're trying to find correlated data. And lastly, if you need administrative processes, don't have the people who are doing the administrative processes on the same process that your customers are using. Run that even as a separate, even microservice with maybe in a separate set of API calls that are admin only and authenticated differently and secured differently and not published, right? So that's like an off customer process. 12-factor apps, by the way, tons written. There's even a beyond 12-factor apps, which I can't remember the company who wrote that, but you can find lots of exposition about 12-factor apps, which is actually almost like 15 years old now. Let's see, I'm just going to check for a second. Looks like we're good on questions. We'll answer the bulk of the questions at the end, but I just want to make sure in case there's anything burning. So it looks like we're good thus far. Okay, so we just spent 30 minutes talking about designing, because that's where the most important decisions are made, right? Is the decisions you make at the front end will have huge impacts years later, right? But now we're going to talk about that evolution from designing to implementing, and then we'll get to implementing in like a little bit more detail. So just to rehash this, scoping is super important, right? So it's not enough just to write a bunch of RESTful web services intelligent talking to each other, right? You have to take in the consideration, the runtime and operational aspects of a distributed system, especially around things like scalability, reliability, high availability. All of the ilities need to be considered for a robust microservice design. So it's not just about being in a single business context on one dimension. It's about how do you design for failure? How do you loosely couple? How do you scale? How do you deploy? How do you test? All amazingly in scope for a robust microservice design. How do you distribute transactions efficiently? Are you calling a bunch of other services? Well, you might need to cache that, especially if there isn't frequently changing data, or even if it changes once every 10 seconds, but you're making 1,000 calls a second, you might want to cache that because that might save you 10,000 calls. So you want to think about distributed transaction efficiencies, because when you go to microservices, you're trading intra-process calls, memory calls, for over-the-network calls and an increased amount of complexity. So make sure you're thinking about how your microservice has to make all these calls to other services, and if there's dependencies there, both in how you call and how you are called, think about offering a way to cache some of those context switching mechanisms. Service scaling obviously is important. A lot of those mechanisms will be handled by programs like Kubernetes or auto scaling inside of EC2 or scale sets inside of Azure. Like whatever it is that you're using, right? You want to make sure that your service can scale and be deployed in an almost automated and dynamic fashion without user intervention. So that's an important consideration. Data consistency is important, and making sure that you are the only one who can talk to your data store is incredibly in scope from going from designing to implementation. So when you actually implement a data store, make sure that your API and your administrative API are the only ones that can talk to the data store. If someone else can talk to your data store, and just trust me on this, I know this from hard experience, they will wreck it, your service will fail, and then you'll realize that you probably shouldn't have given them access to your data store. Avoid that mistake. Leverage my failure. And then you want to be clear about what your service availability is. If you're doing a recommender, for example, you can be like, well, 1 out of every 100 calls we're going to fail. Okay, that sounds great. As long as you know, okay, so then how is the presentation layer going to handle that failure if that's your published SLA, right? But you do want some resiliency to faults, especially if the business needs you to be resilient. If every time you loaded Netflix's page and all of a sudden it was like, well, it's not loading, well, that would be kind of a horrible user experience. But if components of the page fail and they're not necessarily impactful to your experience, that doesn't even matter. As long as I'm seeing what things that I'm looking for streaming videos and episodes and TV shows and movies, then I'm probably okay. Now, when I start going to look for something specific and I can't find it, my resiliency requirements might go up. So, and to say this is that make sure you're minimizing service disruptions, especially as you go through the life cycle of deployment and retirement and new feature delivery and maintenance. Try to make it as invisible to the user as possible. Ideally, the user never knows that you're down, ever. I didn't mention this earlier, is that Eric Evans wrote a book called Domain Driven Design. I believe it was in 2004 or 2005, right? And the idea here is that it's still about the domain model of focusing on one business context, one bounded context as possible. Why are we talking about the bounded context again? Because you want to make sure that you don't cross the bounded context. Again, if you're doing billing, then just do billing. If you're the billing team's credit card processor and that's your microservice, then don't get into GPay or like PayPal or Venmos. Don't get into those guys. Your focus, your bounded context is just on the credit card pieces. So you want to make sure that it's scoped for that, right? And you can use something called a context map, which is good from a business derivation, to show which subdomain is yours, bound that context, and then there's your microservice. It all starts from the business. That's how you derive the microservices context. So just remember that. Remember that the internal models of your microservices, what they do, what they access, the data they need, are all controlled by their bounded contexts. And external models like the APIs are used for this intra-service communication. So what you publish, by the way, might be very different than what you do internally. And that's good because we want that abstraction layer. It's like an extension of the facade pattern. We want our customers to deal with the facade that we've put out. We don't want them to actually see what's going on the back end. We just give them what they ask, right? Most of us don't want to see exactly how the sausage is made, right? We don't want to see how our food is made. Not because we don't clean. That's what the health inspector report is for. We can trust that, right? We don't want that. But at the same time, we're like, I just want a steak. As long as it meets health inspector, I don't really care. Just give me the steak. That's all I want. I don't want to know about the process that you went through. I'm not super interested in that. And that's the same with our APIs. We want to talk to the API, get the data that we've asked for, and move on. We don't care if it came from cloud, MongoDB, Java. We're not, doesn't matter to us. By the way, this last statement, look out for the bounded contexts that are kind of crossing over or bleeding into each other. That happens a lot. When you have contexts that are kind of crossing over with each other, caching is going to be your friend. If you keep pulling information and you're in billing, you keep pulling from profile, you need to start thinking about caching data so you're not pulling from profile so much, just as an example of two services. It is worth mentioning that most startups are not starting with microservices. I think it was Kelsey Hightower was tweeting back in 2018. He said, man, I feel really bad for all these startups who are doing microservices on Kubernetes because they're paying a high complexity cost right off the bat for something that isn't necessary for the business, right? He also, by the way, that same year tweeted and said, hey, if you run Kubernetes and you think you're going to get a relational database service out of the box, he's like, talk to me in a year and a half after you put 12 people on that project, right? So where do you start? Well, I think going directly to a microservices architecture is risky. Instead, start with a monolith. And the minute your monolith starts getting complicated, refer to my reference to Ward Cunningham from 2003, where he's like, technical debt is that feeling you get when you go to make a change. If the feeling's good, you're like, yeah, we can make changes to that thing all day long. Then your monolith has not yet become an anchor. If you go to make a change and you're like, oh God, we got to talk to this module and that's just like super complex and we got to integrate with this team, and that feeling of complexity, that's when you want to start slicing things off. Don't get me wrong, you can design your monolith to have service boundaries inside of it, even inside of a single process. And then later on, you just segment them out. You just put an API in front of it, have them make API calls, and I make that sound trivial, it's really not. But as long as you're thinking in that direction from the moment you design your monolith, you can get to microservices a lot easier. So the bottom line here is that as complexity starts to rise, start breaking things out in microservices. By the way, this picture comes from Martin Fowler, and I'm like, why is there a bee there? I was like, why is there a bee in this picture? I was like, okay, fine, we're moving on. All right, so here's a couple other things to think about when you're moving from designing to implementation, right? Is that you want to favor rapid feedback and change, you want to reduce inertia, find a balance between using managed services and off-the-shelf products and off-the-shelf libraries instead of rolling your own. There needs to be a balance there. I was working at a company last year and they decided to create their own Kubernetes identity access management policy engine. They basically wrote their own identity provider. And there were like 5 in the enterprise that we could have used. And of course, that whole project failed because they spent 6 months doing identity instead of focusing what their core business was, which was actually something else with IoT. So don't reinvent the wheel. Use a third party. Remember, the business doesn't necessarily want you to write anything if it already exists. Remember, keep the business in mind, keep the customer in mind. So eliminate accidental complexity. And then, make sure that you're relentlessly improving your work and auditing what you do and refactoring and improving. That actually makes the work better, faster, and keeps the technical debt out of the equation. Remember, we want you to loosely couple. That's what the APIs are for. Again, if you're relying on another service, make sure you look at caching. If you're relying on another service too much to cache, then you might need to replicate that data into your data store somehow. Don't worry. Your DevOps, SRE, operations folks will gladly help you figure that out. Or your DBAs if you still have them. I don't know why DBA is no longer a cool word. Everybody's a data engineer now, but it's still a necessary function. So remember, crossing context boundaries, as I just mentioned, is expensive. If you keep having to talk to these other services to function, then that's a dependency. Figure out how to minimize that as much as possible. Now, I've been talking about all this decentralization. Remember that you're still going to need centralized authentication, centralized logging. You might actually need single sign-on, because do you really want your user to log into all of the different microservices at the same time? Probably not. That's going to be a bad user experience. It's going to drive them crazy. You might not want to be responsible for all of the presentation layer, right? Because if you do one team to do that, then that will be their sole job. That might be good so that you can just focus on delivering data and not focus on the presentation layer, because keeping up with Firefox, Safari, and what was the other thing I saw? Edge, like in the new version of Microsoft's browser. It's like, do you really want to be in that game? If you love it, awesome, go for it. If you don't, then just focus on backend services and support the presentation team. auditing, session management, caching, that might all need, like session management. Do you want to be responsible for tracking someone's session throughout the entire lifecycle? Maybe there's a session microservice whose job it is so that you can retrieve session state, or maybe it comes across the wire. Maybe it's a cookie. There can be other ways to approach that. So just know that you do need to figure out whether you're going to centralize or decentralize client access. That can always be a concern. You know, again, potatoes or potato, it just depends on what your team can support. Most of the models I've seen have gone to a centralized model instead of a decentralized model, especially since most products are going to have about 20 microservices that support them. Don't want to do logins for each of that. You want to centralize that as much as possible. I mentioned the facade pattern already, which is basically known as the abstraction pattern. It's where you interact with the API, and what goes on in the back end you don't see, which is awesome. There's a lot of different micro and macro iterations of that from a code standpoint versus a client interaction standpoint. But basically, it's about going to a proxy who then acts on your behalf. And so you want the client to interact with the proxy, and you can do whatever you need to on the back end to make that proxy work. All right. Looking good. All right, what about state? Because we've got about 13 minutes left, a little less because I want to make sure I leave room for questions. How can we maintain state? So we got two main options. One, you can maintain it in a database. You can have the client send it. But the bottom line is that if you need state, you're going to be the one to maintain it. So you're going to have to figure out that concern. Again, you could use a caching solution, or you can use a more permanent data store. And the technology doesn't matter because that's why we're using microservices. You use what makes sense, right? I did mention this earlier also, is that micro front ends are your friends. So having a presentation layer, hopefully managed by a team that's dedicated to that, is awesome because it allows you to present data to them, and they in turn can use these micro UIs to present back. So you might have to present a micro UI within a presentation context, but you don't have to do the whole thing. You don't have to worry about browser compatibility or any of those pieces. Your job is just to present a widget, in a sense, a micro UI concept back to the front tier of your app. And so that's awesome. Because front-end developers and back-end developers, I know there are a lot of people who are full stack, but typically people are better at one thing than the other. They're really good at presenting on the front end, and they really specialize in high-end, low-latency transactional back-end services. So it helps with basically breaking up that kind of monolithic presentation layer. And that way you can cover mobile, you can cover desktop. You can just let that team focus on it, and you can be less concerned. You just need to present your widget, and your widget will get handled by the presentation team. Talked about designing for failure, so making sure that you're ready for your components to fail, and how will you gracefully support that. And then, application frameworks that support it, right? There's a bunch. So in many cases, by the way, if you implement, like, for example, Spring Boot, or, something older like Dropwizard or some variation thereof, Flask even, is that these libraries and frameworks will come with microservice ready implementations. Oh yeah, so here's some things about Spring Work and Spring Boot, Dropwizard, Spark for like the Java community. Node has several frameworks. Python has several frameworks, all supporting microservice-oriented application frameworks. Okay, so here's a quick summary of some best practices. One, use immutable APIs. Doesn't mean you can't add to them, but they're not mutative. So if you offer pizza, hamburgers, and tacos, you want to add sushi, again, my earlier reference, you can add sushi, you can add whatever you want to the equation, but don't remove what you've added unless you give it a long communicated cycle so people can refactor their apps. But it's still better, like if you want to get rid of tacos, just point tacos to whatever the new thing is. Maybe the new thing is taquitos. You're going to go to like a taco burrito. That's fine. Just make those API calls go to the new area, but don't get rid of the old ones if you can. Because remember, that's a contract. And people have designed for that contract, and you don't want to break the contract. That's a bad user experience or a bad internal team experience for them. You don't want that. Stick with one business domain per service, not an M service. That's a typo on my part. I'm not making up a new word. It's just service, right? And the database access is only through an API for external services. So nobody can talk to your API, to your database, except for your API and your API only. So nobody else gets direct access to your database. Cross-cutting concerns should be centralized. That's the recommendation. So security, presentation layer, logging, caching, right? Session, that should all be centralized. Make sure your infrastructure team, right? Your infrastructure is ready for distributed computing. If your network is flaky, don't do microservices. That's not going to work for you. Fix that first, and then go to microservices, right? Use frameworks, right? Don't reinvent the wheel. People have been doing this for a long time. And remember that when you do distributed computing, when you go from monolith to microservices, you're going to need more observability and traceability than you've ever needed before. See, before it was just an inter memory call. You were just calling another module in memory. So there's no problem. You don't have to worry. There's no network there. You're just going from memory to memory. If that failed, by the way, you would have seen it right off the bat. But now, because you're running across a network, and that network could be 10 gigabits in speed, that service could still fail. Do you know when that service fails and how does it heal? You need configurable you need to be able to toggle observability. You need to go from no observability to ridiculous amounts of observability in one little turn or flip of a switch. Make sure you're using CI/CD pipelines. Make sure that you are using one database per microservice, or at least one, and make sure nobody else can access it. And then remember this, and this is a very opinionated statement, but I'm gonna make this clearly. Conway's law basically says that you're gonna design services the same way that your organization's communication structure works. So if you were designed in a monolithic way from an organizational standpoint, you will design services in a tightly coupled monolithic way. If you wanna change that, you gotta change your organization. At least slice off one group of people who are going to work on one microservice and make sure there's security, operations, architecture, and developers in there along with some testers, whether that's QA or whatnot. And that team needs to go independent, and you need to organize that way. If you don't, I promise you your mindset and your organizational communication structure is going to inhibit your ability to go to microservices. At the end of this presentation, by the way, is a bunch of useful links and deeper dives into John Lewis and Martin Fowler and all of these people who have talked about these topics, because I just gave you a fire hose of information, and I just want to make sure that if you want to go deeper, here it is, so you can actually dive into all of these concepts even more, and answer questions like how big is a microservice and how do you do battle tested standards and what do you mean by circuit breaker, right? Or synchronous calls. Ooh, synchronous calls. Synchronous calls will really slow you down, so make them async if you can. But there's useful links here at the end of this deck. So we do have some recommended training. So we have basically a technical introduction to microservices, architecture training for microservices, a microservices engineering boot camp, and of course, if you really want to dive into the underlying technologies that nowadays are considered the modern supporters of microservices, you can get right into Kubernetes, Docker, and we'll play with Maven and Jenkins and some of the other tools that can help you get to a microservices implementation. As always, if you need more information or you're looking for any training on any topic, you can visit exitcertified.com to get started. There is a plethora of classes and every technology that you're looking for, it's there. So, all right. So we're at the end of our presentation. So now we're going to open the floor up for any questions that have arisen.
Awesome, Michael. That really was a intriguing lecture. Thank you so much. There is one question already queued up. Any high-level UI design recommendations for interactions with this microservices architecture?
So Enrique, let's see, any high-level UI design recommendations for interaction with this microservices architecture? I'm going to just say that right off the bat, no, I don't really have a good answer for that, because I mainly work on back-end services, and I've avoided the treacherous front-end UI. So if you work in that, you've got my admiration and respect right off the bat, because I don't have a good answer for that. I have seen a lot of teams implement the presentation layer and do the micro UI layer, but I have not done it personally, so I don't have any firsthand experience that I can talk about there. So I apologize, but I don't have it. So kudos to you for tackling that, because it's a very from my perilous domain, having to keep up with all the standards around the browsers and whatnot.
There was a comment in the chat window from Alex asking if the slides and video will be provided so that they can pass it off to their coworkers. So we will be sending out a PDF copy of the slides, and we're going to share a recording of the webinar. So we'll send that out by the end of the week. And if you want to pass that off to your coworkers, I think that's great.
There also was another question by anonymous attendee who wanted to know if there's any processes to help figure out what the bounded context should be. So there is a reference link in the previous slides that will talk about bounded context. From a process standpoint, I recommend that you grab a copy off of Safari Books Online or whatnot of Eric Evans's domain-driven design. the main process that you're looking for is the context map. What is the value stream flow of all the processes that go from customer through the business back to the customer? And when you identify those value streams from a business perspective, those can really help you figure out what are all the different components that make up that value stream and how can those be microserviced out. For example, you heard me talking about inventory and billing and profiling. So you really want to start with a value stream map that derives exactly how a customer goes into the business and how a customer goes out, like what they get out of the business. And that process of deriving a value stream will help you figure out exactly what you need. Now, most of the time we talk about value streams in terms of like back-end processes, like how do we deliver like virtual machines or containers or whatnot. But it's also very valuable to start from the customer all the way in to the value that they derive from the business. Good. All right. Any other questions around microservices about implementation, design, architecture, or whatnot? Okay.
Very thorough presentation again. Thank you so much, Michael. To all of our attendees, thank you so much for taking some time out of your day to learn a little bit more about microservices. Visit our website to contact us, to find out more about training, to learn about some savings that you can save on right now. We'll hang out here for just a couple more moments, but if that's all, then thank you so much.
Yeah, thank you, everyone. Thank you for participation.